June 6, 1944, 6:30 hours, Omaha Beach, Sector Dog Green, Normandy, France. The flat bow of the LCVP crashes into the submerged sandbar, jarring the teeth of the 30 men packed inside the steel tub. The sea spray blowing over the gunnels is freezing, but the air already carries the sharp, acrid smell of burning diesel and cordite. Inside the craft, men of the American 29th Infantry Division stand shoulder to shoulder, gripping their M1 Garands with white knuckles. Some are praying silently, others are staring blankly at the scarred grey steel of the ramp. Above the roar of the surf and the churning boat engines, a terrifying, rhythmic thrumming echoes across the beachhead. The coxswain hits the release lever. The heavy steel ramp slams down into the knee-deep water. Before the first boot can even touch the surf, the sound tears through the morning air. It is not the familiar, rhythmic rat-tat-tat of an American Browning M1919, nor the slow, steady chug of a British Vickers. It is a continuous, deafening roar, a mechanical scream that sounds less like a firearm and more like heavy canvas being violently ripped in half. The water in front of the ramp erupts in a chaotic geyser of sea foam and red mist. The men surging forward do not just fall, they are violently swatted down by a literal wall of lead. The weapon producing this nightmare is firing at an incomprehensible 1,200 rounds per minute. 20 full metal jacketed bullets are breaking the sound barrier every single second. Up on the bluffs, positioned behind the reinforced concrete lip of Wider Stanzenist 62, a German gunner rests his shoulder against the wooden stock of his weapon. The gun smoking in front of him does not look like a traditional, beautifully crafted firearm. It looks industrial, crude. It is a long, rectangular shroud of ventilated sheet metal. As the barrel overheats, glowing a dull cherry red in the dawn light, the gunner's assistant pops open a door on the right side of the weapon, yanks out the scorching barrel with an asbestos pad, and shoves a cold one into the sleeve in less than 5 seconds. The feed cover slams down, the bolt is racked, and the screaming begins again. This is the Maskenengewehr 42, the MG42, Hitler's buzzsaw. To the terrified Allied soldiers pinned behind Czech hedgehogs in the rising tide, it is a weapon of unparalleled futuristic destruction. But the true terror of the MG42 was not just its blistering rate of fire, nor its devastating psychological impact on the beaches of Normandy or the frozen steppes of the Eastern Front. The real nightmare for the Allied High Command lay in a much more pragmatic, logistical reality. How the gun was made, how much it cost, and the brilliant, unorthodox mind that brought it to life. To understand the revolution of the MG42, you have to look back to the weapon it was designed to replace, and the fatal flaw of German perfectionism. By the late 1930s, the German Wehrmacht had developed an infantry doctrine completely unique among the world's militaries. While American and British squads were built around the individual rifleman, the German squad was built entirely around the machine gun. The riflemen existed primarily to carry extra ammunition, spot targets, and protect the machine gunner. The core of this tactical philosophy was the Einheitsmaskenengewehr, the universal machine gun. A single weapon that could be carried by one man on a bipod for infantry assaults, but could also be mounted on a heavy tripod for sustained suppressive fire, or bolted onto vehicles for anti-aircraft defense. Their answer to this requirement was the MG34. Designed by the legendary Heinrich Vollmer at Mauser, the MG34 was a masterpiece of gunsmithing. It was beautifully balanced, highly accurate, and functionally brilliant. But it was a peacetime weapon, built for a parade ground army. Creating a single MG34 required taking a massive 100-pound block of high-grade tool steel and submitting it to over 150 hours of painstaking milling, lathing, and turning by master craftsmen. Steel shavings piled up on the factory floor as the heavy block was slowly whittled down to a 26-pound firearm. The tolerances were incredibly tight, fitting together with the precision of a bespoke Swiss watch. When the invasion of the Soviet Union began in 1941, this precision became a death sentence. In the freezing, sub-zero mud of the Eastern Front, dirt and grit easily worked their way into the meticulously machined receiver of the MG-34, jamming the delicate mechanism. Worse still, as the war expanded across multiple continents, the German war machine realized they were mathematically doomed. At a cost of 327 Reichsmarks and 150 hours of labor per unit, Mauser and the other contracted armories physically could not mill steel fast enough to replace combat losses, let alone arm new divisions. The German High Command faced a massive crisis. They needed a new universal machine gun. It had to shoot faster. It had to shrug off the mud of the Russian winter, and above all else, it had to be manufactured at a fraction of the cost and time. The military brass sent out a desperate request to industry. But the solution that would forever change the face of warfare wouldn't come from the legendary armories of Mauser, Walther, or Krupp. It was about to emerge from a modest sheet metal factory in Saxony, drafted by a man who possessed no weapons experience whatsoever. Late autumn 1939, Döbeln, Saxony. The concrete floor of the metal und Lacquierenfabrik Johannes Grossfuss vibrates with a rhythmic, earth-shaking thud. The air inside the cavernous warehouse is thick with the smell of vaporized machine oil, ozone from spot welders, and the sharp, metallic tang of hot iron. Under the harsh glare of industrial drop lights, a massive 50-ton hydraulic press descends with a deafening crash. When the heavy steel dies separate, a worker in a grease-stained apron reaches in with heavy tongs and pulls out a perfectly formed, three-dimensional piece of steel. Standing a few feet away, holding a clipboard and watching the process with intense, calculating eyes, is Werner Gruner. Gruner is not a gunsmith. He has never apprenticed at Mauser, nor has he spent decades learning how to hand-file the sear of a rifle to a mirror finish. He is a mechanical engineer specializing in mass production. The Grossfuss factory doesn't make weapons, they manufacture sheet metal lanterns, stamped typewriter parts, and simple agricultural equipment. But when the German Heereswaffenamt, the Army Weapons Agency, secretly circulated a tender for a cheaper, faster-to-build machine gun, Gruner saw an engineering puzzle waiting to be solved. He had studied the prized MG-34 and immediately saw its fatal flaw. It was built like a sculpture. Traditional gunsmithing required a machinist to take a solid billet of expensive tool steel and painstakingly carve away everything that wasn't a gun. Gruner realized this was an archaic waste of time and material. He approached the design of a firearm not as a weapon, but as an industrial enclosure meant to house a mechanical reaction. To Gruner, a machine gun was no different than a car fender or a lantern housing. It just needed to contain controlled explosions. Instead of milling, Gruner turned to metal stamping. The process was a form of violent industrial origami. Using heavy-gauge, cold-rolled sheet steel, a flat blank was fed into a massive hydraulic press. With hundreds of tons of pressure, the steel was folded, bent, and punched into shape in seconds. The main receiver of Gruner's new weapon wasn't carved. It was stamped as two separate halves of sheet metal. These halves were then clamped together and rapidly fused down the middle with a continuous seam weld. Where the MG-34 required delicate, hand-turned screws, Gruner's design utilized crude but unbreakable industrial rivets. The resulting shell looked entirely alien to the aristocratic Prussian officers of the Military Procurement Board. It was entirely devoid of elegance. It had a square, boxy shroud meant to improve cooling, sharp edges, and ugly, visible weld marks. It looked like a piece of farm machinery. But it was practically indestructible, and more importantly, it was incredibly cheap. To make this stamped shell function as a weapon, Gruner needed an action that could handle the immense stress of continuous, rapid fire without shaking the sheet metal apart. Working alongside fellow engineer Eduard Steck, they perfected a short-treacle roller-locked mechanism based on earlier captured Polish designs. It was a stroke of mechanical genius. When a round was fired, the barrel and the heavy steel bolt recoiled together for a fraction of an inch, locked securely by two small steel rollers. As the assembly moved backward, wedge-shaped camming tracks welded to the inside of the stamped receiver forced the rollers inward. This instantly unlocked the bolt, freeing it to fly backward at tremendous speed, ejecting the spent brass casing before a massive recoil spring slammed it forward to strip a new round from the belt. Because the parts were relatively light and the unlocking action was so violently efficient, the cyclic rate was pushed to the absolute limits of physics. It fired so fast that individual shots could no longer be distinguished by the human ear. In April 1941, Gruner stood on a dusty firing range to demonstrate his prototype, designated the MG3941, to the skeptical brass of the Heereswaffenamt. When the trigger was pulled, the resulting roar echoed off the hills, kicking up a storm of dust and shredding the target downrange in seconds. The officers were stunned, but the true shock came when Gruner presented the manufacturing data. The beautifully crafted MG34 required 150 man-hours and cost 327 Reichsmarks to build. Gruner's crude, stamped sheet metal gun took just 75 man-hours and cost only 250 Reichsmarks. Production time and material waste had been cut squarely in half. The weapon was resistant to dirt, easy to mass-produce in factories completely unrelated to arms manufacturing, and possessed a rate of fire that exceeded anything on the battlefield. With a few minor modifications, the weapon was officially adopted. By 1942, the first stamped, welded and riveted guns began rolling off the assembly lines and onto the trains heading east. The MG42 had been born, and it was about to meet the freezing hellscape of the Russian winter. November 25, 1942, the outskirts of Arzew, Soviet Union. The temperature has plummeted to 20 degrees below zero. In a shallow, fortified trench carved into the frozen earth, a squad of German infantrymen huddle in their Feldgrau greatcoats, breath pluming like chimney smoke in the moonlight. The mud that had plagued the autumn advance has now hardened into an iron-like permafrost. For the finely tuned Mauser rifles and older MG34s, this climate is catastrophic. Microscopic ice crystals and grit freeze inside the tight tolerances of milled steel, locking bolts tight and turning automatic weapons into heavy, useless clubs. But resting on its bipod on the parapet is Werner Gruner's creation. Its crude, stamped steel receiver rattles slightly when the gunner shifts his weight. Those loose tolerances, mocked by traditional gunsmiths, are precisely what keeps the weapon alive. The cold doesn't matter, the dirt doesn't matter. Across the snow-covered expanse of no man's land, a sudden sharp blast of a whistle pierces the wind. Out of the tree line, a massive wave of Soviet infantry emerges, their brown wool coats a dark contrast against the white ground, shouting battle cries as they charge. The German gunner doesn't panic. He simply exhales, settles the wooden stock against his shoulder and squeezes the trigger. The night erupts. A brilliant, continuous tongue of yellow flame leaps from the muzzle. The sound is not a series of individual shots, but a singular, terrifying roar, a high-pitched, mechanical shriek that tears across the frozen steppe. Tracers pour from the barrel in a solid, unbroken laser of red light, sweeping back and forth across the advancing line like a demonic scythe. The sheer density of the fire is mathematically devastating. If an enemy soldier sprints from cover to cover, exposing himself for merely 2 seconds, the MG42 will put 40 full metal-jacketed rounds into that space before he can dive back down. This blistering speed was not an accident. It was a deliberate tactical choice based on the German doctrine of the cone of fire. High Command believed that soldiers in modern combat only presented themselves as targets for fleeting microseconds. Therefore, a weapon needed to saturate that brief window of time with as much lead as physically possible. Within seconds, the Soviet charge falters, pinned down by a sheer volume of fire that defies human comprehension. But the immense cyclic rate comes with a severe physical cost: heat. After just 250-round belts, the thin, stamped shroud is smoking. The barrel inside is glowing a dull, translucent orange, its rifling beginning to warp under the intense friction of 1,200 copper-jacketed bullets per minute. If the gunner keeps firing, the barrel will permanently droop, or worse, the heat will cause a live cartridge to cook off in the chamber, exploding the weapon. This is where Gruner's pragmatic engineering shines brightest. The assistant gunner taps the shooter's shoulder. The firing stops. With his right hand protected by a thick asbestos pad, the assistant slaps a heavy latch on the right side of the receiver. A long steel door swings open, popping the searing hot barrel out at an angle. He yanks it free, tossing it out of the trench onto the snow, where it hisses and boils violently in the freezing air. With his left hand, he slides a fresh, freezing-cold barrel into the sleeve, snaps the door shut, and slaps the feed cover down. The entire process takes less than 5 seconds. The gunner racks the bolt, and the buzzsaw roars to life once again. As the surviving Soviet troops retreat, the reality of the MG-42 sets in. It is not just a weapon, it is an industrial machine of suppression. By the end of 1943, the production numbers out of Germany are staggering. Factories that used to make lamps, typewriters, and bicycles are now stamping out thousands of receivers a month. More than 400,000 units will eventually be produced before the war's end. The psychological impact on the Allies is so severe that the weapon earns distinct, terrified nicknames on every single front. To the Soviets, it is the Linoleum Ripper. To the British, the Spandau, named after the Berlin district where some tracer ammunition was manufactured. To the Americans, it is simply Hitler's buzzsaw. The terror was so pervasive that the United States War Department was forced to take action to prevent mass panic among incoming replacements. They produced a specialized, classified training film for fresh recruits heading to Europe, specifically designed to demystify the MG-42. In the scratchy black-and-white reel, an upbeat narrator confidently assures the young GIs that the gun's bark is worse than its bite, claiming its high rate of fire is actually a fatal flaw that wastes ammunition and makes it wildly inaccurate. It was a desperate piece of propaganda, a psychological bandage for troops who were about to step off landing craft into the most lethal interlocking fields of fire ever engineered. The men on Omaha Beach would soon discover the grim truth. The training film had lied. But as the Allies eventually pushed inland, securing beachheads and capturing these terrifying weapons intact in the bunkers of the Atlantic Wall, American ordnance officers began to look past the carnage. Sitting in dimly lit command tents, they took the stamped steel guns apart, examined Gruner's brilliantly simple roller-locked bolt, and realized they were staring at the future of infantry warfare. The race to copy the buzzsaw had begun. February 14, 1944, Aberdeen Proving Ground, Maryland. Sleet pelts the frosted windows of the heavily guarded ordnance testing facility. Inside, the air smells of Hops No. 9 solvent and hot coffee. Gathered around a scarred wooden workbench, a team of American engineers and military brass stare down at the disassembled guts of a captured MG-42. It has been stripped of its menacing aura, its stamped metal shell and roller-locked bolt laid out like organs in a surgical autopsy. The United States Ordnance Department has seen enough casualty reports from the hedgerows of France and the mountains of Italy. They want this weapon. They want its manufacturing efficiency, and they want its terrifying suppression capability. But there is a catch. To integrate into their logistical supply chains, it must fire the standard American 3006 cartridge. The reverse engineering contract is handed to the Saginaw Steering Gear Division of General Motors. The directive is straightforward: copy Gruner's masterpiece. The resulting American prototype is proudly designated the T-24. Months later, an American gunner lies prone in the Maryland mud, settling behind the T-24. The top brass stand behind protective glass, holding stopwatches and notepads, eager to hear the legendary buzzsaw roar with American brass. The gunner racks the charging handle, takes aim downrange and pulls the trigger. Bang, bang, click. The gun falls dead silent, a catastrophic failure to feed. Frowning, the gunner clears the mangled brass casing, reseats the belt and tries again. Bang, click, another jam. The demonstration is a humiliating disaster. The engineers had made a fatal miscalculation. The German 792 cartridge was nearly a quarter-inch shorter than the heavy American 3006 round. When the draftsmen at Saginaw redimensioned the receiver to fit the larger bullet, they fundamentally misunderstood the complex, violent geometry of Gruner's feed mechanism. The brilliant, loose-tolerance sheet metal that made the original gun so reliable suddenly became a chaotic liability when the underlying math was flawed. The T-24 project is quietly and unceremoniously scrapped, a victim of hubris, assuming that copying was easier than inventing. But the ghost of the MG42 refuses to die in the archives of Aberdeen. Fast forward a decade. The ashes of World War II have settled, but the Cold War is freezing over. In the humid, stifling design rooms of the Springfield Armory, weapons designers are still chasing Gruner's shadow. They take the ingeniously simple, reliable top-cover feed mechanism of the MG42, the very system that allowed a gunner to rip a continuous belt of ammunition into the chamber without a single hiccup. They marry this feed tray to the gas-operating system of another German wonder weapon, the FG-42 paratrooper rifle. The resulting amalgamation of captured German engineering is heavy, loud, and uniquely American. They call it the M60. Within a few short years, the M60, affectionately and derisively dubbed the Pig, is hacking its way through the dense, sweltering elephant grass of the Ia Drang Valley in Vietnam. When an American door gunner leans out of a A-1 Huey helicopter, raining suppressive fire down on the jungle canopy, he is pulling a trigger that actuates a feed mechanism drawn directly from the mind of a Saxon sheet metal engineer. Every time the M60's belt advances, it is Gruner's ghost doing the heavy lifting. Yet the ultimate vindication of the MG42 does not happen in the jungles of Southeast Asia, nor in the testing grounds of Maryland. It happens back in the very soil where it was born. By 1955, West Germany is permitted to rearm, forming the modern Bundeswehr to stand as the first line of defense against a potential Soviet invasion through the Fulda Gap. The new West German army needs a standard machine gun. They aggressively test the latest American, British, and Belgian designs. They look at the newest innovations in gas piston and rotating bolt technology. And then they look back into their own history. They dig out the original, surviving blueprints of the MG42. They realize that despite millions of dollars and a decade of global weapons development, no one has actually managed to build a better universal machine gun. The stamping process is still cheaper, the roller-locked bolt is still brutally effective, the quick-change barrel system is still unmatched in the heat of combat. Rheinmetall, a massive German defense contractor, simply dusts off the old tooling. They recalibrate the weapon to fire the new NATO Standard 7.62x51 cartridge. They tweak the heavy bolt to lower the cyclic rate from a completely insane 1,200 rounds per minute to a slightly more manageable 800 to 1000, saving ammunition and barrel life. They update the alloys and swap the wooden stock for modern polymer. They christen this new weapon the MG3. November 12, 2023, NATO Enhanced Forward Presence Battle Group, Pabrad Training Area, Lithuania. The damp, freezing fog clings to the pine trees as a German Leopard, a main battle tank, tears through the muddy terrain, its massive diesel engine vibrating deep within the chests of the observing infantry. Following closely behind, a squad of modern Panzer Grenadiers dismounts from a Puma infantry fighting vehicle. They are clad in advanced Kevlar composites, equipped with night vision goggles, thermal optics, and encrypted digital radios. They look like soldiers of the future, but as the squad leader motions for suppressive fire to cover their advance, the heavy weapons specialist drops to the wet earth, kicking out a folding steel bipod. He flips open a stamped metal feed cover, lays in a belt of 7.62 NATO ammunition, and racks the charging handle. When he pulls the trigger, 80 years of technological advancement instantly evaporate. The sound that rips through the Baltic forest is not a modern, synthetic crack. It is the exact same mechanical scream, the exact same tearing of heavy canvas that haunted the men of the 29th Infantry Division on Omaha Beach and the Soviet conscripts on the steppes of Argev. Aside from a slightly slower cyclic rate and a modern polymer stock, the MG3 barking in the Lithuanian mud is physically indistinguishable from the MG42. The soldiers using it are the great-grandsons of the men who first carried it, yet they are relying on the exact same stamped steel receiver, the exact same quick-change barrel door, and the exact same roller-locked bolt. It is a staggering anomaly in military procurement. In an era where stealth fighters, guided drones, and computerized rifles